Humanity has existed for a long time, speculating on the possibility of life in other universes. Because of the development of the James Webb Space Telescope, currently the most advanced telescope ever built, it's possible that the time has come to address this question. While observing Proxima Centauri, the star system closest to Earth, located only 4 light-years away, scientists have noticed some strange occurrences from one of the planets that are part of the system, Proxima B. These peculiarities, which have created a stir among astronomers, are artificial lights. But precisely what are these lights, and do they suggest the existence of intelligent life on the planet? Come along with us as we investigate the potential of the James Webb Space Telescope's revolutionary discovery of artificial lights in the city that could change our understanding. At present, Earth remains the only known planet that supports life. From the very beginning of human development, we've questioned whether there may be life elsewhere in the universe. To investigate this cosmic question, Jill Tarter, an American scientist, and Thomas Pearson began the search for extraterrestrial Intelligence SETI program in 1984. The goal of this initiative was to capture spaceborne radio signals, as radio waves are more likely to travel long distances. The 42 radio telescopes that make up the array of the Allen Telescope in the mountains of the Sierra Nevada, California, can detect these signals. However, despite these efforts, no conclusive signal from extraterrestrial life has been associated with success. The James Webb Space Telescope, JWST, was launched with the current task of researching exoplanets with distant orbits around stars. As the world's largest telescope constructed, JWST is positioned about 1,000 miles away from Earth and is equipped with highly sensitive instruments. Its potential to accomplish groundbreaking discoveries is immense. Decades ago, we had no knowledge of planets outside our solar system. Since then, the system has grown to over 4,000 exoplanets discovered orbiting stars other than our Sun. NASA has indicated that the potential for these planets' early signs numbers in the trillions, suggesting the possible existence of life beyond our solar system found in plants from other planets. The Galileo spacecraft, on its way to Jupiter, aimed its instruments at Earth and identified clear signs of life by detecting what is referred to as the red edge of vegetation. This biosignature involves a unique combination of infrared and red light reflected by plant matter. For instance, a planet like Earth, surrounded by dense jungles, would display a prominent, easily recognizable red edge signal. The JWST is capable of measuring this arc of red on distant planets. Earth-like planets situated in the habitable zone around their stars could provide useful information about the conditions present on these planets beneath their atmospheres. As light passes through a planet's atmosphere, JWST may detect changes in frequencies that are easy to identify, employing spectroscopy to study molecules and atoms in the atmosphere. These absorb specific frequency ranges, creating a unique fingerprint that can be analyzed by JWST. This method allows scientists to determine a planet's atmospheric composition and evaluate its potential for supporting life. The atmospheres of Earth-sized planets, similar to our own, composed of oxygen, carbon dioxide, and nitrogen, could be possible signs of life. By looking for unusual elements, we could also determine whether intelligent life exists. For example, chemicals made with chlorofluorocarbons, CFCs, frequently found in refrigeration and cleaning, can be identified if Earth is being studied by extraterrestrials from a distance. If JWST finds CFCs in a planet's atmosphere, it would be definitive evidence of technological advancement. Despite this, life on exoplanets may differ drastically from life on Earth. Even typical Earth organisms, such as microorganisms that thrive in extreme environments, may appear alien. These species can survive in environments with temperatures up to 250 degrees or in highly acidic conditions with pH levels below 3. Since Earth-like planets are more likely to support life than those with extreme temperatures or acidity, it may be wise to focus on those that provide ideal conditions. It is likely that planets have surface temperatures conducive to liquid water and revolve around stable stars. Our Sun, classified as a yellow G-type star, is fairly common. These stars typically have shorter lifespans, which restricts the amount of time available for life to evolve. In contrast, red dwarf stars, more common and less hot than our Sun, have longer lifespans. This provides additional time for the possibility of life evolving into organisms with complex structures. The initial missions will concentrate on one planetary system belonging to the TRAPPIST-1, around 40 light-years from Earth. It revolves around a quiet red dwarf star and consists of 7 rocky planets, 3 of which are similar in size to Earth and lie within the so-called habitable zone, where liquid water could potentially exist on their surfaces. Despite the smaller size and bulk of the TRAPPIST-1 star compared to our Sun, it radiates light similar to that of Earth's Sun. The close orbits of the planets around this star make it an exciting target for study. Proxima Centauri. A red dwarf star just 4.25 light-years away also presents an enticing opportunity for detection. Proxima bears evidence of intelligent life. Centauri is much dimmer than the Sun, implying that any planet in its orbit needs to be closer to the star to sustain life. In 2016, astronomers discovered a planet with 1.3 times the mass of Earth within the star's habitable zone, the Goldilocks zone, with favorable conditions for the existence of liquid water. Proxima B, circling Proxima Centauri, could be a planet without air and dormant. Its close proximity to the star, only 4.6 million miles away, exposes it to intense sunlight and winds that could destroy its atmosphere. Despite this, Proxima B may still receive enough sunlight to allow for liquid water to exist on its surface. The planet is believed to be tidally locked, meaning only one side faces the star, much like the Moon does with Earth. Proxima Centauri only accounts for 18% of the mass of the Sun, and its light output is only 5% that of the Sun's. This suggests that Proxima B might appear devoid of life and lifeless, but the right conditions, such as a setting able to hold water that could become liquid with heat, may exist. Despite the fact that extreme circumstances on Proxima B, such as high-energy radiation from solar flares, could make life difficult, unless the planet has a protective magnetic field similar to Earth's. Additionally, the tidal locking of Proxima B produces extreme variations in temperature between its daytime and nighttime sides, but it remains a fascinating subject for study. The candidate for potential life, many questions about its magnetic field and atmosphere remain unanswered. Models indicate that tidal locking could result in rapid failures of the environment, particularly on Earth's night side. Volcanic activity replenishes the atmosphere, but with or without this process, Proxima B's magnetic field may be susceptible to atmospheric escape. Despite these challenges, Proxima B remains one of the most promising planets for researching signs of life. If Proxima B's atmosphere is able to support oceans, it could offer a glimmer of hope for the existence of living things there. Researchers are eager to study this planet further, especially by making use of the JWST, which may be capable of detecting artificial lighting in the evening. The detection of city lights on Proxima B would be revolutionary, indicating the possible existence of an advanced civilization. However, scientists remain cautious. The technology used by the JWST is still developing, and even though artificial lights could be a sign of intelligent life, they might also result from natural occurrences like volcanic ash, lightning strikes, or unusual atmospheric events that could cause signals resembling artificial lights. To confirm whether these lights are truly artificial, astronomers will need to continue their investigation and verify their conclusions. The JWST will keep an eye on Proxima B and other potentially habitable exoplanets to create a more complete understanding of their surfaces and atmospheric conditions. If Proxima B's lights turn out to be artificial, it would mark one of the most significant discoveries in scientific history. The possibility of finding intelligent life on Proxima B or any other exoplanet raises significant philosophical issues about humanity's place in the universe. Locating extraterrestrial life may challenge the notion of Earth as the only place where life can grow and could spark unprecedented international collaboration. This finding would also emphasize the significance of space exploration, urging further investments in the technologies required for continued cosmic exploration. The search for Proxima B's artificial lighting represents a thrilling chance to respond to the inquiry of whether we are truly alone in the universe. As the JWST continues to return additional data, the aspiration of finding evidence of intelligent life beyond Earth becomes increasingly tangible, bringing us closer to a solution to one of science's most profound questions. Does Proxima B contain an advanced civilization? If this finding is true, it could unlock the future of space research and interstellar communication, growing our understanding of life in the cosmos. As humanity pushes forward in its quest to look into the stars and see what we find by means of instruments such as the James Webb Space Telescope, the potential to comprehend the universe's implications of finding life beyond Earth extends far beyond scientific curiosity. They may alter our cultural and philosophical perspectives. If we were to confirm the existence of intelligent life elsewhere, it would challenge the notion that Earth is the unique home for life in the universe, pushing us to reconsider our role in the vast areas of space. The concept of meeting other civilizations opens a multitude of possibilities. It could encourage a new era of cooperation between nations as a result of the discovery. Extraterrestrial intelligence would offer a common goal that transcends borders. A finding of this nature would undoubtedly inspire awe and wonder, uniting humanity in its search for answers to some of the most profound questions we have ever asked. What does it mean to be alive in the universe? Are we alone? Furthermore, finding evidence of extraterrestrial life would accentuate the significance of space exploration and the need for ongoing investment in cutting-edge technologies. Not only would advancements enable us to continue searching for extraterrestrial life, but they could also aid us in resolving difficulties on Earth, including climate change, resource management, and energy production. The technology used to look for city lights or other indications of intelligent life on distant exoplanets, like Proxima B, might also open doors to new breakthroughs in energy generation, communication, and space travel. The hunt for signs of life on Proxima B serves as a significant illustration of how extensive our ambitions have become. As we refine our observational instruments, such as the JWST, we are inching closer to unraveling the mysteries of distant worlds. The discovery of artificial lights on a nearby planet in a star system could be just the beginning of a new chapter in human comprehension, where we can look beyond the confines of our solar system to answer questions that have remained constant over centuries. With each new discovery, whether on Proxima B or another exoplanet, we are making advances in understanding not only the existence of life elsewhere, but also the possibility of interstellar communication. If intelligent life does indeed exist outside of Earth, it could one day open the door to interactions that transcend space as we know it. The technological advancements needed to study these distant worlds could, in turn, provide humanity with tools to better understand the nature of the cosmos and our connection to it. As the JWST and future space missions continue to push the boundaries of what we can observe, it becomes increasingly clear that the universe contains more than we can comprehend. The search for intelligent life, while still in its early stages, represents a monumental leap forward for science. The journey to uncover these secrets will take time, but with each breakthrough, we come closer to answering one of the most fundamental questions. Are we alone in the universe? If the lights detected on Proxima B turn out to be artificial, it would not only provide evidence of the existence of intelligent life, but also redefine our perspective on life's potential across the universe. This discovery would, without a doubt, determine the future of space exploration, guiding future generations of scientists, explorers, and astronomers as they continue to venture into the unknown. For now, humanity stands on the precipice of a new era in space exploration. The James Webb Space Telescope, along with other future missions, will continue to search the heavens, seeking clues that could unlock the greatest mysteries of all: the existence of intelligent life beyond the world we live in, and the possibility of communication across the stars. As we move forward in this journey, we are bound to encounter difficulties and questions that push the limits of our current knowledge and technology. But the advantages of discovery, whether we find artificial lights on Proxima B or uncover something completely unanticipated, could be transformative for the coming years of humankind.